Okay, so the next thing we're going to be doing is something called quartiles. So we're going to have a data set here, and I'm going to call it data set, well, it's a new lesson, so we'll start at data set A. So the values for data set A are going to be 2, 3, 7, 8, 9. They're going to be in order already, so we won't have to put them in order. 15, 16. 17, 18, 19, 20, 21, 21 again, 22, 30, 45. Okay, so what we have our n for this data set, the number of points. We have 5, 5, 5, and 4. We have 19. And let's say I asked for the median. So I want to know what the median of this data set was. So the median, and remember we had the position of the median, and the formula that I gave you for position of median was n plus 1 over 2, which in this case is 19 plus 1 over 2, which is 20 over 2, which is 10. But 10 is not the actual median. The actual median is going to be, that's the position of the median. The actual median is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the 10th number, which in this case is 16. So the actual median is 16. So the position of the median was 10. The actual median is 16. So that's all well and good, and we already knew that. Now let's imagine this is our data set. So that's the lowest number, and that's the highest number. And they're lined up from lowest to highest. And what we have is, we know that we have kind of like our halfway through point. And this, over here, the median cuts the data into equal halves. So half the things are below the median, half the things are above the median. And what we could do is we can also cut it into quarters. So that would be a quarter, a half, 3/4. And then the name for that is, as you may have surmised, quartiles. So quartiles are the points. And we're going to call, so there's kind of two names. So Q1 is going to be the point that divides the first quartile from the second quartile. And that's going to be Q2, and that's going to be Q3. So often what they say is, they say that this over here is the first quartile, and that's the second quartile. Q1 is the point that separates the two. Another name for Q2, of course, is the median, and that's Q3 is going to be the point that separates these two quartiles. Or another way of looking at it is, this is the number that's a quarter of the way through, and this is the number that's 3/4 of the way through. Or Q1 is the point where a quarter of the numbers are below and 3/4 are above. And here 3/4 are below and 1/4 is above. So I'm going to give you a formula for that. This one I've kind of made up, but I feel it's kind of accurate probably. So the position of the Q1, is going to be like the n plus 1 over 2, except it's going to be n plus 1 over 4. And the position of the Q3 is going to be the 3/4 version of it, which is going to be 3 times n plus 1 over 4. And those are going to be the formulas for the positions of these quartiles. So in this particular case, it's going to be 19 plus 1 over 4, which would be 20 over 4, which would be 5. And this would be 3 times 19 plus 1 over 4, which would be 15. So 5 and 15 are the position of the various quartiles. So Q1 is going to be 1, 2, 3, 4, 5. So the actual Q1 is going to be, and we're definitely running out of room here, is going to be 9. And the actual Q3 is going to be the 15th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which is 21. Another way of doing it would be to count 5 from the end. So 1, 2, 3, 4, 5, but that's not official. And so that's our points. So we have our median, we have our Q1, and we have our Q3. So we're going to discuss some quick things that go along with that. So first there's something called the range. And the range is going to be the highest number minus the lowest number, which is going to be, in this particular case for this data set over here, is going to be 45 minus 2, which is 43. So the range is 43. Then we're going to have something called the interquartile range. So the interquartile range, and the interquartile range is going to be Q3 minus Q1. Now notice it's not going to be the positions, it's going to be the actual value. So it's not going to be 15 minus 5. In this case, it's going to be 21 minus 9. It's going to be 21 minus 9, which is 12. So that's going to be the interquartile range. Then there's going to be something called the semi-interquartile range. And that's just defined as the interquartile range divided by 2, which would be in this, so in this case it would be 12 over 2, which would be 6. Okay, and the last thing we're going to do with these things is we're going to do something called a box and whisker plot. That's the actual name. So it's called a box and a whisker plot. And what we do, it's sometimes, I think I've seen it in other places, called a 5-point plot as well. And the reason it's called a 5-point plot is that it's a kind of a number line with 5 points on it, and it's going to be the lowest point, Q1, Q2, Q3, and then the highest point. So 1, 2, 3, 4, 5 points. And then to make it look like a box and whisker plot, we are going to make a box out of it and put a line over there. And then we have our box and our whiskers, whiskers. Okay, well, I can't draw it. But box, and then the whiskers are sticking out on the side. So, in the case over here, if we're going to draw a box and whisker plot for the last data set, I'll make it kind of prettyish. And you kind of want to put the numbers sort of in the right spot. So it's going to be 2, 9, and we're going to have a box. And a fairly long thing to this. And these numbers are kind of close to each other. And then you would actually put the numbers down. So it would be 2, 9, 16, Q3 is 20, and the highest number is 45. And there's your box and whisker plot. Sometimes, I'm not going to insist on this course, but sometimes there's a concept of an outlier. And an outlier could be defined into, I've seen 2 definitions for an outlier. One of them is actually, I think that it's 1.5 times the interquartile range. So it's 1.5 times the interquartile range. Or it's more than 3 standard deviations from the mean. So that's an outlier is a point that's far away from the normal data set, either 1.5 times the distance of the IQR or 3 standard deviations away from the mean, so fairly far. If we were going to call a point an outlier on a box and whisker plot, I'm not going to recalculate all the various things, but we would put it as a dot. So if I was calling the 45 an outlier, then it would be a dot. And that's how we would do the box and whisker plot. Okay. Time for an example on this video? I do. So let's say here we have data set B, and it's going to be a frequency table, of course, to make things interesting. So we'll say it's 7, 13, 18, 20, 22, and we'll make this 43, 30, 864. And so what I want is you're going to find the following. So we're going to find the median, Q1, Q3, the interquartile range, the range, the semi-interquartile range, and a box and whisker plot, assuming that there's no outliers. So box and whisker plot. Okay, so as I usually recommend in these cases, this would be a good time to pause the video and try it out yourself. But I am going to power ahead and solve for it. So, the n here is 91. The n is 91. So the median, the position of the median, is going to be 91 plus 1 over 2, which is 46. And the 46 number, so there's 43 numbers that are 7s, and the 46th number would actually be over here. So the 46th number is going to be a 13. So the median is a 13. Now the position of the first quartile is going to be 91 plus 1 over 4, which would be 92 over 4, which would be 23. And so the actual Q1 is going to be the 23rd number, and the first 43 numbers are all 7s, so Q1 is going to be a 7. And then the position of Q3 is going to be 3 times 91 plus 1 over 4, which, well, I'm going to achieve it. It's going to be 23 less than 91. So it's going to be 69. And then the actual Q3 is going to be the 69th position, which is, so the first 43 are this, and then up to the 73rd is going to be this, which means that Q1 is actually still over there. So Q1 is actually 13. So this box and whisker plot is not going to be actually a 5-point plot. It's going to be something a little less than that. Right? So if I'm going to make the box and whisker plot for this guy, the lowest value is going to be 7, but Q1 is also 7, so there's actually no left whisker here at all. The Q2 is 13, but the Q3 is also 13, so there's also no dividing line over there. So that's going to be 13, and then the highest number is going to be 22. So our 5-point plot, our box and whisker plot, is actually, in this case, a pretty aborted whisker with box with half a whisker, and not even much of a box, kind of split. Very quickly, the other things I asked for. The interquartile range is going to be Q3 minus Q1, which would be 6. The semi-interquartile range would be 6 over 2, which would be 3. And the range is going to be the highest minus the lowest, which is going to be 22 minus 7, which is 15. And that is all the possible values for that. And we'll stop the video over there.